welcome to Basics of Finite Element Analysis Part 2. This is the 6th week of this course. Today is the 4th day of the week. In the last week, we had calculated elements of K and F matrices, and these calculations were specific for a 3-noded triangular element, that is a linear triangular element. What we will do is something very much similar to what we did in the last class, but with the difference that we will be using all that knowledge to a 4-noded rectangular element. So, what we plan to do today is calculate elements of K matrix and F vector for a 4-noded rectangular element. Okay. So, these are my coordinates x and y, and we know that my rectangle was such that its coordinates are aligned to the axes, x and y axis, and then I had developed approximation functions for this 4-noded element in global local coordinate system x bar and y bar, and the 4 coordinates are 1, 2, 3, 4. So, these are the 4 nodes, and the length of one side of the rectangle is A, the other side is B. So, these nodes are 0, 0, A 0, A B and 0 B. So, now first let us look at the transformations. So, x, so if there is a point x in the global coordinate system, that can be written as, so the x coordinate of any point in a global coordinate system is equal to x bar plus x1 e. What is x1 e? So, x1 e is this distance. It is the x coordinate of the first node in the global coordinate system. So, any point in local coordinate system can be mapped to that in the global coordinate system for the x direction using x, this relation x is equal to x bar plus x1 e. Agreed? Okay. Similarly, y is equal to y bar plus y1 e. What is y1 e? Y1 e is this thing. So, in the global coordinate system, the coordinates are x1 e and y1 e. x1 e, y1 e are coordinates of node 1 in which system? Global coordinate system. And in the local coordinate system, the coordinates of first node are 0, 0. So the other thing is dx, if I differentiate first equation, is same as dx bar, and dy is same as dy bar. So, these are the transformations, and using these transformations I can calculate values of S matrix and different S matrices. For instance, we had developed that S00 ij is equal to psi I This is the original definition for elements of S00. Now, here we note that psi I is expressed as function of x bar, psi j is expressed as function of x and y, and same with psi I also, right. But I have shape functions or interpolation functions in the local coordinate system, which we had developed earlier. See, these are the interpolation functions. We had developed our interpolation functions using the local coordinate system, but my expression for S is in the global coordinate system. So, if I have to use these expressions for these approximation functions using the local coordinate system, then I have to transform dx into dx bar, and I also have to change the limits, right. So, this I can rewrite in the local coordinate system as psi I x bar y bar psi j x bar y bar dx bar dy bar. Why can I write straight away dx bar dy bar? Because I know that dx is equal to dx bar and dy is equal to dy bar. My limits are in the local coordinate system what? So, my initial limits, so for a rectangular element, if I have to integrate, I have to integrate it 2 times. So, the integration would have happened from x1 to x1 plus a and y1 to y1 plus b, and because this is the eth element, I have to put superscript e everywhere. Now, in the local coordinate system, these limits change. So, x1 becomes 0 and x1 plus a becomes a, y1 becomes 0 and y1 plus b becomes b. Okay. Similarly, S I j 0 1, I can write it as a double integral 0 to a 0 to b. So, now I am directly writing the expression in local coordinate system. It is psi I del psi j divided by del x bar dx bar dy bar. I can directly write that. Similarly, S I j 10 equals double integral 0 to a 0 to b del psi I over del x bar psi j dx bar dy bar, and then S 11 I j equals del psi I over del x del psi j over del x bar. So, x bar is in both places dy bar. So, what is S12? It is the first derivative of psi I with respect to x bar and derivative of psi j with respect to y bar dx dy. And I have two more expressions, S21 that equals 0 to A, 0 to B, y bar. And finally, S22 ij that equals partial of psi I with respect to y bar, partial of psi j with respect to y bar dx bar dy bar. Okay. So, these are the formulas, and my psi I and psi j's, the expression for those psi's are already given here, psi 1, psi 2, psi 3, psi 4. So, for different psi's I can compute all the individual terms of the S matrix. Okay. So, while we are doing these computations, we must just note some facts, that when I integrate from 0 to a 1 minus x by a square dx bar, what I get is a by 3, and also if I integrate x bar by a into 1 minus x bar by a dx bar, I get a divided by 6. So, because we will encounter these integrals, so I can directly replace them, and similarly 1 minus x bar by a integral from 0 to a dx bar equals half of a, and integral from 0 to a x bar over a dx bar equals a over 2. So, we can use these standard mathematical facts when we are computing integrals for S11, S12 and so on and so forth. So, what I will do is I will write down expressions for S00. So, S00 AB is AB over 36. So, this is S00. 4, 2, 1, 2, 2, 4, 2, 1, 1, 2, 4, 2, 2, 1, 2, 4. Then S12 equals 1 over 4, 1, 1, minus 1, minus 1, minus 1, minus 1, 1, 1, minus 1, minus 1, 1, 1, 1, 1, minus 1, minus 1. This is also equal to S21 transpose of S21. And then S11 equals B over 6A and that is 2 minus 2 minus 1 1 minus 2 2 1 1 minus 1 1 2 2 1 minus 1 minus 2 2. And then finally S22 is equal to A over 6B 2 1 minus 1 minus 2 1 2 minus 2 minus 1, minus 1, minus 2, 2, 1, minus 2, minus 1, 1, 2. And finally, the force vector. So, here is a question: if there is an element A times B wide and force per unit area is F, then what will be these 4 values? What by 4? F times, and what is A? AB. So, it will be F AB divided by 4, and these values will be 1, 1, 1, 1. So, this completes our coverage for linear 4 noded rectangle element also. So, what we have done till so far in these 4 lectures is that we have computed elements of K and F matrices for a triangular element and for a 4 noded rectangular element. Now, in our finite element equation, which is that is the equation at the element level, the overall equation is what? K times U equals an F vector plus there is another vector which is Q vector. Elements of this matrix are calculated by a surface integral. Elements of this vector are calculated by a surface integral. So, we have learned how to compute surface integrals. What we have not done, what are elements of this matrix? They are computed through what? Through a boundary integral, right, because Qi equals Qn psi I ds. We have developed this expression earlier. So, we have learned how to calculate surface integrals for in context of stiffness matrix and force vector, but we have not figured out, or I have not discussed it till so far, how do we calculate this term. So, in the next 2 lectures we will cover these this term, the boundary integral, and that will complete our coverage of 2-dimensional finite element analysis at the element level. So, once we are comfortable at the element level, then we will learn how to do assembly of element level equations. So, that is what I look forward to talking about tomorrow, and we will meet tomorrow. Thank you.